has all the hallmarks of a good disaster movie. An impending crisis that threatens to engulf the world. From an almost benign start, a hardly perceptible change in global temperature, the Earth could suddenly topple into crisis, reducing large tracts of land to desert and wreaking havoc on our culture.
For proponents of the greenhouse effect, it heralds something akin to an apocalypse. An Earth parched and scorched by the sun. A climate in chaos. Nor is it a theory supported by a few cranks. It's been endorsed by the great and the good, by politicians and academics. There's only one problem. There's mounting evidence that it's not true.
Certainly, when it comes to the weather, our impression of what's going on is often wrong. An Earth Day conference at the University of Missouri in the heart of the United States. One of the speakers at the conference is Pat Michaels, a professor of environmental science from the University of Virginia. He begins his lecture by asking the predominantly scientific audience how far the summer of 1988 differed from the normal in Missouri.
The group estimate is that Missouri averaged 2.2 degrees Fahrenheit above normal for the calendar year 1988.
In fact, it wasn't above average, it was below average.
You not only got the magnitude wrong, you got the sign wrong. And I've given this talk about 120 times in places that were colder than normal in 1988, which was much of the United States. Every crowd has estimated that it has been warmer than normal. I believe you are all very intelligent individuals. That's why you are here. So where did you get that perception? I would like to know.
The notion of a warming, the notion that a warming is catastrophic, is sort of drilled in to people to the point where it seems surprising that anyone would question it. And yet underlying it is very little evidence at all. In fact, there's ample evidence to the contrary.
And some experts are saying now that the whole world is heating up because of a global greenhouse effect. That is heat caught in the atmosphere by air pollution that prevents its escape. NBC's Robert Hager explains.
In Washington, a Senate committee heard some scientists say the phenomenon known as the greenhouse effect is here.
The problems unaddressed have the potential for turning the world into a form of chaos not greatly different from that produced by global war.
Information from satellites has convinced most scientists that average temperatures will rise by 2 to 5 degrees Celsius over the next 100 years.
But is there any real evidence of a forthcoming disaster?
No, I wouldn't think that there would. Wouldn't think there was any evidence for a catastrophic change in our climate at the present time.
No evidence at all?
There's no evidence at all.
The case for the greenhouse theory rests on 4 pillars. On the one hand, there's the factual evidence. Firstly, that the Earth's climate record shows temperature has increased and sea levels have risen. And secondly, that carbon dioxide, or CO2, has been the primary cause of these changes. Then there's the third pillar, which is not based on evidence from the past or the present, but on predictions of climate models that a doubling of CO2 will result in increases in global temperature of between 2 and 5 degrees. And finally, there's the underlying physics, which it is widely assumed proves that CO2 is a greenhouse gas and that further increases will result in increases in global temperature. So let's start with pillar 1 and the facts about the Earth's climate record. It's far from easy to get an accurate picture of what's happening to the world's weather. Our evidence is dependent on thousands of individual measurements taken every hour of every day at weather stations throughout the world. It may be Basildon or Phoenix, Calcutta or Buenos Aires, but the techniques are the same. In addition to temperature measurements, each weather station collects data recording the amount of rain and the hours of sunshine. From these measurements, 60,000 every day, 22 million measurements a year, meteorologists try to discern what is happening to the Earth's climate. Analysis of temperature change over the last 100 years, carried out by the team at East Anglia University in England, has played an important role in support of the greenhouse case.
In the recent past, the last century or so, the global mean temperature has increased by about half a degree Celsius, that is. Doesn't sound like a very large amount, but it is a very significant and important change.
But such claims are not universally accepted. Richard Lindzen is Professor of Dynamic Meteorology at the Massachusetts Institute of Technology in Boston.
I think most scientists I know feel it would be very difficult to say anything about this record as it stands. I'm reasonably confident that given that record alone, few people would plausibly say that this indicates man has created warming.
There are a number of problems with the data. The first of which is that the weather stations are not evenly distributed around the globe.
Land is only about 30% of the Earth's surface. If you want to take a global average, you're already hoping that this 32% will be representative of the whole. So, for instance, you have St. Helena Island representing 1/3 the Atlantic Ocean. And that's a little bit questionable.
The weather stations may not be uniformly spread over the Earth, but in addition, they often tend to be situated in towns. In Phoenix, not only is the weather station in the middle of the city, it is also next to the airport runways, surrounded by acres of tarmac.
The surface right here, the rocks and all the asphalt at the airport, that just holds the heat in. We'll be 10 degrees warmer than anybody here overnight, because it's even noticeable when you drive away from here.
Phoenix is like every other city. As it has grown, the temperature has gone up. And because many of the world's weather stations are situated in towns, the temperature record is potentially threatened by this effect, the urban heat island phenomenon.
We've been able to detect heat islands in cities as small as 300 people. And the second we move into an urban environment, no matter how small, and begin to replace the natural vegetation with concrete, you would create something of a distortion in the temperature pattern. It's an effect that can add up to 2 or 3 degrees. And if we look at the issue of global warming, and we say how much warming do we think we should have seen or will see in the future, it's on the order of 1 or 2 or 3 degrees.
Dr. Balling has studied urban heat island effects in hundreds of cities throughout the United States.
We have to be careful when we look at people who say, I have detected global warming, because what they may have detected is urban warming.
Professor Wigley defends his data and plays down the urban heat island effect.
You can estimate what that residual effect might be, and we believe that it's quite small.
I agree, it is a small effect in terms of the total area of the globe that's being affected by urbanization. The problem is that most of our measurements come from these areas.
And an awful lot of the weather stations are in towns, aren't they?
A number of weather stations are in towns. There are a number of ways that one can account for that problem. The obvious way is just to eliminate those stations from the data set that you use to calculate the large area average temperature values.
But presumably there must be lots of towns where you don't have data from around them, so it's very difficult to tell whether there's been an urban effect or not.
That's right. And I should say that this is an area of ongoing research and still of some concern.
Dr. Balling's results would seem to justify that concern.
We looked at 1,000 stations in the United States that came from very small towns, averaging no more than about 5,800 people. And we looked at the temperature pattern from those cities over this century. We found out that most of the United States has cooled this century, not warmed.
Furthermore, new data from space has made the land record more doubtful. Until recently, we've had no alternative but to rely on thermometers and weather balloons. But now, for the first time, satellites are giving us another source of information. Dr. Spencer at the NASA Space Center has been able to analyze satellite data to produce snapshots of global temperature, each one equivalent to tens of thousands of separate thermometer readings taken by hand. In February of 1983, the hottest areas are clearly visible over southern Africa and Australia, while in August, the warm areas shift into the northern hemisphere.
We've found that we can monitor globally averaged atmospheric temperatures with a high level of precision, even on a monthly basis. We're estimating the precision at about 1/100th of a degree per month.
Unlike the thermometer data, the satellite information is evenly spread and does not suffer from the urban heat island effect. Over the last 10 years, the thermometer record has shown an underlying upward trend. But according to the satellite information, the Earth was rather warmer in the first half of the 80s and rather cooler in the second half.
The trend in the thermometer data is only about 1 to 2/10ths of a degree, which doesn't sound like much, but it's enough to be a significant difference with the satellite indication of no trend. Over the entire 10-year period of time, there was no net warming or cooling.
For the first time, satellites have given us an alternative to the land-based data, but they show no increase. So there's a flaw in the first pillar that supports the greenhouse theory. The urban heat island effect and the satellite information point to question marks over the data on which claims of warming have been based. But even if we accept the thermometer data as accurate, whether there's been a temperature increase or not depends on the timescale you choose. Would you accept that over the last 10 years there's been no overall increase in global temperature?
No, I wouldn't accept that. But that is a question that may be irrelevant in the greenhouse context. The greenhouse effect is a century timescale warming.
The warming Professor Wigley is referring to comes from this graph of temperature over the last 100 years, which shows an underlying increase of 0.5 degrees Celsius. The problem is that the trend depends on the period you choose to examine.
If you started it someplace else, if you ended it at someplace else, the trend changes. And so it's clearly not a record you draw a straight line through and say this is warming.
You mean that if we took the last 50 years, then it would tell a different picture?
Yes, absolutely. Last 50 years it does nothing. Went down and then went up.
And if we chose the years from 1930 to 1970, the average temperature actually falls fairly sharply. We don't have the data to extend the graph backwards much beyond the last 100 years, but there is evidence that there have been times when it's been warmer than it is today. Medieval records show that vines were grown throughout Britain, and remains of a beetle, a species of nettlebug, has been found in York 1,000 miles north of its current habitat in the Mediterranean. So if we had thermometer records going back for 1,000 years, it could well show a fall in temperature since then, rather than a rise. Doubts over the data and problems with the time base have led Dr. Rizzo, who studied the effects of carbon dioxide on climate for the past 20 years, to be dismissive of claims that the world is warming.
Some people claim that there may have been a 0.5 degree centigrade warming over the last 100 years. This is really tenuous. You look at the real world, let's say over the past 100, 150 years or so, and you find that there has been no significant warming.
But perhaps more than global temperature rise, it's been predictions of increases in sea level that has encouraged impressions of impending catastrophe. entire cultures are apparently faced with disaster.
As the children play, year by year the waters are rising around them. They'll be adults by the time the Pacific swamps the 9 sandy stubs that are the islands of Tuvalu. If forecasts are correct, the seas round here will rise by about 2 feet over the next 50 years.
It's not only the media. The scientists themselves are not averse to making the situation appear dramatic. Steve Schneider is one of the United States' leading global warming theorists.
If the sea level rises, and those projections range anywhere from a few tens of centimeters to maybe a meter or so in the next 100 years, that by itself is not that serious except to places that are low-lying, the Maldives and Venice and probably London. But what really is serious is if the warming of the oceans causes an increase in the energy source for severe storms, then you get a higher probability of more intense hurricanes or other severe storms driven by ocean evaporation.
That's particularly important in a country like Bangladesh, where there are tropical cyclones that even today kill many thousands of people. In some parts of the world, I think there's very strong reason to believe that the consequences would be severe.
But as with temperature changes, the facts about sea level rise tell a different story. The Oceanic Institute near Cape Cod, 250 miles north of Manhattan, is one of the most influential organizations studying the sea. For many years, Dr. Aubrey, who heads coastal research at the Institute, has traveled the globe investigating changes in sea level.
Can you tell whether the sea level has gone up or not over the last, say, 100 years?
No, we can't unambiguously say exactly how much the ocean has risen over the entire globe. Some tide gauge stations show the sea level rising over long periods of time. Others show sea level falling during other periods of time. The problem is that the land is also moving up and down. In some places it moves up considerably fast, in other places it falls, it subsides fairly fast. So you're measuring the sea level against another level that's moving up and down. And that leaves you with a lot of uncertainty about how much the ocean is moving versus how much land is actually moving. If you look at the British Isles, you see the same thing in a very small portion. The northern part of the British Isles, sea level is falling. South part, the sea level is rising. In the past, people have averaged different sets of tide gauge records, and they've averaged those tide gauge records for different periods of time, say from 1930 to 1960 or 1910 to 1980. And every time you take a different set of stations and a different set of dates, you can come up with whatever answer you want, in effect. I think on a time scale of the past 100 years, the errors are so great in trying to estimate what the global sea level is doing that we cannot come up with a useful answer that's going to be usable for predicting what sea level may do in the future.
We may not be able to predict what will happen in the future, but Dr. Aubrey has no doubts about the evidence so far.
There's no evidence that sea level rise has accelerated due to global warming.
While direct measurements have been unable to confirm that sea level is rising, in 1989 there appeared to be evidence of sea ice melt. When submarines passing under the North Pole reported that the ice at specific points was less deep than it had been 10 years earlier. But Julian Parron at the British Antarctic Survey is sceptical.
Just 2 snapshots of Arctic sea ice 10 years apart, even if it did indeed show a thinning, wouldn't really be significant compared with data taken from long-term monitoring of sea ice extent.
The submarine observations are contradicted by the only reliable evidence coming once again from satellites, which for the last 12 years have given us a daily picture of sea ice extent in the Arctic and Antarctic.
It says no change. It says there have been changes from year to year, but taken as a whole, you cannot say that there has been, statistically speaking, any significant change in sea ice concentration around the Antarctic.
The satellite data has only been with us since the late 1970s, but recently analysis of the amount of salt in samples of ice taken from the edge of Antarctica, created from snow that has fallen over the last few hundred years, has indicated that the present levels of sea ice extent are far from exceptional.
The closer the open water is to the sites where you take your measurements, the more contaminated the ice cores become with sea salts. It's quite clear that there are periods of 5 to 10 years at a time round the Antarctic in which sea ice extent has been much less than it is today.
So, as with the sea level, changes in the amount of sea ice do not support the idea that the world is getting warmer. Not surprising, therefore, that supporters of the greenhouse effect back off the actual data under scrutiny.
What we know about the greenhouse effect is not just based on the data. The data is the ultimate way of proving that the models are right or wrong, but because of the natural variability of the system, we cannot say yes or no.
Therefore, trying to mine the record by carefully looking at every bump and wiggle, to me, is a waste of time. It's like trying to figure out the probability of a pair of dice by looking at the individual rolls. You can't look at individual rolls. You got to look at averages. So I don't put very much stock in looking at the direct evidence.
So, from the actual climate record of the Earth, from the measurements of thermometers on land to changes in sea level and ice extent, there's no convincing evidence of either a rise in temperature or an increase in sea level. The first pillar of the greenhouse theory, proof of global warming from the climate record, turns out to have no substance.
Like the first pillar, the second pillar also relies on our past evidence of the climate, but this time to support the claim that carbon dioxide causes an increase in temperature.
We know that when the Earth was 5 degrees colder 20,000 years ago, in the last ice age, that there was about 25% less carbon dioxide than during the present warm period, before the Industrial Revolution, that is. We know there was about 50% less methane. So we know that cold times tend to be associated with less greenhouse gases, warm times with more greenhouse gases.
But that's only part of the story. Our knowledge of ice age temperatures and the levels of CO2 comes once again from the analysis of the ice buried within the Antarctic plateau.
Excellent.
Ice cores taken 2,000 meters below the surface have enabled us to look at the last 160,000 years.
This is probably a year or so, perhaps 2 years of snow accumulation. Yes, this is the top end, it's here, so this is the youngest snow, and the bottom we have the oldest snow.
There's no doubt from the record that for the last couple of 100,000 years, temperature and carbon dioxide levels do appear to follow each other. But it's far from clear that carbon dioxide causes temperature to change.
We certainly know that the temperature falls long before the carbon dioxide levels fall.
Is it thought that the decline in temperature actually causes a decline in CO2?
Well, it clearly does. I mean, it clearly, in the end, that the sources of CO2 are reduced and the sinks for CO2 are increased. So there has to be this quite straightforward effect.
So, if the record from the distant past tells us that if anything it's temperature that causes CO2 to change and not the other way around, what does the recent past tell us? One matter over which there is no dispute is that levels of carbon dioxide in the atmosphere have increased substantially. But it's not been a steady increase. CO2 levels rose slowly from the middle of the last century, but it was only in the 1950s that levels started to increase rapidly. But even if we accept the thermometer data, the temperature change, which is supposed to have been caused by CO2, does not coincide with the increases in carbon dioxide.
It's pretty apparent that the lion's share of the warming occurred before the lion's share of the trace gases went in.
Yes, in fact, that's a remarkable puzzle.
So how does he solve it?
In the first part of the century, you see a large natural warming. Well, you know, natural variability's got to go both ways, so why should it be strange that in the next 40 years or so there was a large natural cooling, which was large enough to offset the greenhouse effect?
Michaels has a more straightforward explanation.
There are only so many things that can go against a simplistic theory before you have to admit that the theory is simplistic and needs revision.
So, not only does the climate record fail to prove that carbon dioxide causes temperature change, but if anything, there's evidence to the contrary. The second pillar, supporting the greenhouse effect, turns out to be as insubstantial as the first. The third pillar, supporting the greenhouse effect, is the climate models. Perhaps more than anything else, it's been the predictions of these climate models that a doubling in CO2 will lead to an increase in global temperature of 3 to 5 degrees Celsius by the end of the next century that have sustained fears of an impending crisis. But can we rely on these predictions? Although superficially similar, the climate models are radically different in character from the models used to provide daily weather forecasts. The computer models used to generate the weather forecasts, with which we're all familiar, start from information about the current situation and try to calculate what will be happening over the next few hours and days. The complexity of the mathematics involved means that the models cannot predict with any accuracy beyond 5 days. Changes in climate take place over decades and centuries, so these weather forecasting models are of no use for estimating climate change. Instead, the climate models do not start from the current weather at all, but try to simulate the entire climate of the Earth from first principles. The computer is given the amount of heat arriving from the sun, the laws of physics which describe how heat radiates, and the radiation properties of the atmosphere. It then calculates the temperature of the Earth, the wind speeds, the rainfall, and so forth. The models then simulate the Earth's climate over a number of years and produce an average annual temperature cycle. We can see how the predicted temperature in a single year differs from this long-term average. The red areas are hotter than normal, and the blue areas cooler. But according to the models, with a doubling of CO2, large areas become hotter than the current average. This model, produced by Steve Schneider's department at the US National Center for Atmospheric Research, is one of the world's 5 influential climate models. But if we're to believe the predictions of these models, we must first be convinced that they accurately simulate our current climate.
The point that should be made is that
Dr. Mitchell heads the team at the Met Office in Britain that has developed another of the world's major climate models.
what in general we get is not just the north-south distribution of temperature, but also the large-scale variation across the continents. And this is very much as observed.
They do very well. When we take our models and we let the sun get higher, it gets warmer, and we let the sun go away, it gets colder. I remember once talking to a U.S. congressional hearing about this, and one of the senators said to me, "You mean to tell me you guys have spent $1 billion of our money telling us that the winter is cold and the summer is hot?" And my answer was, "Yes, sir, and we're very proud of that."
Some scientists, however, are less impressed.
I don't think we could speak of the models as being accurate at this point. They're experimental tools. We're trying to forge these tools. To use them in a forecast mode for delicate things like this warming is calling on an accuracy these models simply do not have.
We certainly don't understand the models well enough to take their predictions seriously.
One criticism of the models has been that they fail to take account of all the so-called feedback effects. Some of the most important of these are related to clouds. Professor Jonas is a world expert on the effect of clouds on climate. His experiments are designed to find out how different types of cloud reflect the sun's rays.
The climate models are treating clouds in a very simplistic manner, and this makes it very difficult to include the true magnitude of the feedback effects within those models.
If temperature rises, evaporation increases and more clouds are created. But in turn, the clouds then reflect the sun's radiation away.
This has the effect of giving rise to a smaller amount of warming at the Earth's surface, so that the effect of the increase in temperature due to carbon dioxide is reduced by the presence of the clouds.
These effects are not small.
The energy balance equation tells us that if everything else is equal, if you change the reflectivity of the globe a mere 2% or so, you compensate for a doubling of carbon dioxide because you reflect away more solar radiation. So very slight changes in cloudiness, which are responsible for much of that reflectivity, very slight changes can drastically influence how the world responds to the trace gases.
So given the simplified character of the models, we'd be wise to treat their results cautiously.
They give roughly the right seasonal cycle of temperature. They show that it's warmer at the equator than it is at the poles.
But some of those things you're mentioning are pretty gross, aren't they?
Pretty gross, yes.
If the model didn't show that it was warmer at the equator and cold at the poles, there'd be something seriously the matter.
Yes. Yes, it's more important to know that a model that's used for climate studies reasonably well predicts storm tracks over the North Atlantic, or shows you that the Sahara ought to be a desert.
But showing that the Sahara is a desert is what the Met Office model has failed to do according to its published findings. If you look at its predictions of current rainfall, it shows that as much rain falls on the central Sahara in summer as Ireland and Scotland.
There's no doubt on regional scales of 2,000 kilometers or less, one cannot have a lot of confidence in the model predictions.
Others go further.
I don't believe that there is any good evidence to suggest that we should believe what they are telling us. Right now, they have been predicting that for the CO2 content rise that we've experienced over the last century or so, there should have been a couple degrees centigrade warming, but there hasn't been anything like that. There's a possibility of a half a degree centigrade warming, but that may be due to other causes, or it may not be a real warming at all. It may just be a figment of the data due to problems such as the urban heat island.
Overall, you are confident that the models give an outcome for climate change that we can rely on?
I am convinced that models are the best way of trying to determine what the outcome of increases in trace gases are.
Well, that's a different answer.
That is a different answer, yeah.
The question is, can we at the moment believe in the predictions they're making with any confidence?
Right, could you just be a bit more specific about, you say, predictions?
The most obvious one, the prediction of the effect of carbon dioxide on temperature.
It's difficult for me to, I'm not sure how one can quantify confidence.
We should caution here that it's not that these modelers are incompetent, bumbling people. They're limited by something called the speed of light, and that's why simplifications are made in the models.
So why is anyone taking the models seriously?
I don't know why they're taking the models seriously. It's very difficult for me to understand. Anybody that's actually looked at any of these models, looked at the differences between the models in terms of their predictions for one region and one time, how you could possibly take the aggregate of these models for the globe and its prediction of what's going to happen 50 years from now very seriously.
The third pillar supporting the greenhouse theory turns out to be as flimsy as the first two. So there's only one remaining support for the greenhouse theory, the underlying physics.
To me, and the reason I strongly believe there's a high probability of unprecedented change in the next century, is not based on the performance of the planet in the last 100 years. There are just too many unknown and unknowable factors in the past 100 years. So it's based on the greenhouse physics, so you're exactly right.
The greenhouse physics is supposed to show that carbon dioxide is a greenhouse gas, that it absorbs radiation reflected from the Earth's surface and in turn emits that radiation again, causing an increase in the amount of radiation, or heat flux, arriving on the surface of the Earth, so resulting in a warming of the planet.
We know how much has gone in very well. We know how much more methane there is over the last 100 years. We know about the CFCs and their greenhouse gases too. So we know the greenhouse gases are going into the atmosphere, and therefore we know there will be some warming.
But the assumption that the basic physics necessarily implies a warming is not accepted by some atmospheric physicists.
there are people around, there are a lot of scientists around, not only members of the public, who are saying, as if it's absolutely categorically the case, that if you increase CO2 in the atmosphere, you get heating.
Yeah, I'm saying that that's not at all evident.
CO2 is not the only greenhouse gas, nor the most important. Water vapor is the primary greenhouse gas, along with the other major greenhouse gas, ozone. A number of other trace gases, such as methane, play a minor role. These gases do not simply absorb radiation, they also emit radiation. And like all good absorbers of radiation, they're also good emitters. In fact, they emit as much as they absorb. Furthermore, the way they absorb and emit radiation changes throughout the atmosphere. The radiative process is therefore highly complex, and the effect of any one gas is not the same throughout the atmosphere and is linked to all the other gases.
Additions of CO2 to the atmosphere will certainly cause an increase in the downward flux at the surface of energy, but that will not necessarily change the temperature of the lower layers of the atmosphere. This additional energy coming down from the CO2 at the surface, what I think it will do is it will evaporate more water and put more water into the system. And that will have a lot of ramifications, one of which is the radiative effects, which, as I said before, will tend to produce more cooling by the water vapor, and we can demonstrate that. But in addition, it will produce more cloud, and the cloud will have other effects, such as reflecting more solar radiation. So it's not at all obvious that by increasing the CO2 in the system, that you've actually changed the temperature in the positive sense. You could actually end up with a lower temperature.
Professor Newell is not alone in this view. In a recent paper on the effects of carbon dioxide, Professor Elsässer at the Lawrence Livermore Labs, a major US government research establishment in California, concluded that a doubling of CO2 would have little or no effect on the temperature at the surface and, if anything, might cause the surface to cool. The complexity of the radiation effects of the greenhouse gases is further confused by convection currents, which carry warm air at the surface to higher altitudes.
If you put greenhouse gases near the surface and the air currents short-circuit that greenhouse gas, it won't contribute to warming. If you put a lot in at the surface and take a little away near the top where the heat is deposited by the convection, that could lead to cooling even though you had a net increase in the amount of greenhouse gas. There is no simple, uniform relation between the total amount of greenhouse gas in the atmosphere and the temperature at the surface.
At the very least, we simply don't understand enough about the behavior of the atmosphere to predict the effect of a change in CO2 with any certainty. Even the final pillar supporting the greenhouse effect, the underlying physics, turns out to be as insubstantial as the rest. Although there is no evidence that increases in carbon dioxide are bad for us, it's still easy to think of it as a pollutant. But carbon dioxide is the equivalent of oxygen for plants, the essential life-giving gas. And it may well be that increases in carbon dioxide levels could turn out to be a good thing.
The vegetation of this planet developed and acquired its basic characteristics in an atmosphere that had much more CO2 than that of the present. And logic would therefore tell you that if you have more CO2 in the air, plants will do better. And in fact, this is exactly true.
For the past 3 years, Dr. Rizzo has been growing sour orange trees in enclosures containing double the amount of CO2 than normal. The carbon dioxide-enriched air is continuously pumped into the chambers and escapes up through the top. At the same time, identical trees are kept in exactly the same conditions, but are fed normal air only.
These trees are planted directly into the ground. This chamber here is getting twice the normal amount of carbon dioxide as what is in the atmosphere. You see the trees are growing quite well. They're taller than we are. Over here is a companion chamber that is receiving only ambient or normal air. And the trees here are only half as big as the trees in the enriched chamber. The enriched trees have 180% more volume in their trunks and branches than do the trees in the normal CO2 chamber. I think the interesting question is, how much could we possibly put into the atmosphere, let's say if we burned all of the fossil fuels that exist in the crust of the Earth? It's been estimated that the most we could increase it is about 10 times the present level. And from all of the studies that have been done, 10 times the present level would have no deleterious effects upon animal life, and it would be still beneficial to plants. It's very likely that we are going to need the added benefit of atmospheric CO2 enrichment to feed the generations that are going to come after us.
If there's concrete evidence of the benefits of CO2, and the detrimental effects are, at the very least, questionable, how is it that we've been led to take talk of catastrophe seriously? After all, it's only some 15 years since a rather different global climate catastrophe was in vogue.
There's the ever-present threat of a big freeze. Will a new ice age claim our lands and bury our northern cities? It's buried Manhattan Island before, when great glaciers half a mile thick filled the valley of New York's Hudson River.
You do accept that sort of 10, 15 years ago, people were talking about a global cooling, not a global warming.
People were talking about global cooling 15 years ago, but not everybody. I was one who was not sure.
You say you didn't believe in global cooling, but in your first book you said, I've cited many examples of recent climatic variability and repeated the warnings of several well-known climatologists that a cooling trend has set in, perhaps one akin to the Little Ice Age. Mm-hmm. Well, that was just 14 years ago.
Yeah.
So
I said that because at the time it was true. But you got to be honest. You got to tell things the way they are. I don't mind people quoting what I had to say in the 70s.
But doesn't all of that add up to saying that you're asking governments to spend billions of dollars on a view which is different from one you held a decade ago?
I don't see any problem in saying that people learn. I'm not embarrassed about the view I had a decade ago.
You should remember that when I was going to graduate school, it was gospel that the Ice Age was about to start. And to tell the truth, I had trouble warming up to that one, too. So this is not the first. It is certainly the loudest of the climate apocalypses, but it is not the first.
There may be many reasons why we might want to believe in an apocalypse, but for the scientists involved, some of them are very straightforward.
It's easier to get funding if you can show some evidence for impending climate disasters. In the late 1970s, of course, it was the coming ice age, and now it's the coming global warming. Who knows what it'll be 10 years from now. But sure, science benefits from some scary scenarios.
A lot of people are getting very famous and very well known and very well funded as a result of promoting the disastrous scenario of greenhouse warming.
My suspicion would be that if one has a crisis like this, it's easier to gain funds for the profession as a whole.
I don't think funding directly influences the nature of the research or the approach.
But indirectly?
Well, I can use my own organisation as an example. You're asking me a very difficult question here. My organisation has only one permanent university-funded scientist, and that's me. I have about a dozen research workers with PhDs who are working in the climatic research unit, and they're all funded on so-called soft money. Their existence requires me or us jointly to get external support.
Funding may have encouraged belief in the greenhouse theory, but if you oppose the theory, life can get difficult.
I was warned when I wrote my first paper, which discussed a difference between the climate models and some numbers that I was looking at for the tropics alone, that it would be very difficult and that my funding would probably be cut. And in fact, it has been cut.
Did you believe that at the time?
No. I didn't. I thought that the system was so straightforward and honest that bringing in a new idea and a new perspective into the whole thing, which I thought I did in 1979, would actually be considered to be a positive thing, and that people would like to look at both sides of the argument and then have a debate.
But of course, in some ways, one could say it's been successful in terms of raising funds, that by going around saying there's a crisis around the corner, people are talking about putting in more funds and so forth, and maybe it's worked.
Perhaps it's worked, perhaps I was wrong, but I think that it's going to backfire.
Richard Lindzen has recently said that this whole area of global warming has sort of become a new McCarthyism. And if you don't jump on the environmental bandwagon to stop the inevitable warming that the Earth is going to undergo, that you're going to be ostracized from the scientific community and from everybody else's community, because it's not fashionable to disagree with the environmentalists these days.
I don't know. Neither of us can answer. Of course not. We can't answer that question.
People who have a point of view which may not be the politically acceptable point of view are going to have problems. That's not surprising. I have had experience with editors where I have asked questions as to why something was rejected. And this has occurred with more than one journal, and have been told that your papers are held to a higher standard of review than others. I've been literally told that.
For what grounds did they hold?
Because of what they say. I mean, that's fine, okay, if they want to be that way. I'm a big boy. I've been fairly successful. I know that I would have been more successful, probably if I'd say the world's coming to an end, but I just can't quite bring myself to do that.
Of course, it's not only been the scientists. The media also benefits from a good disaster story.
Storms, cyclones, drought, high winds and floods. A foretaste of global warming, a change in the climate caused by man's pollution of the planet.
The climate is okay does not usually make the headlines. And the best prophets of doom are the ones filmed most.
The rate of change is so fast that I don't hesitate to call that kind of change potentially catastrophic for ecosystems.
There are statements made of such overt unrealism that I feel embarrassed. I feel it discredits my science. And I think there could arise problems where one will need to depend on scientific judgment. And by ruining our credibility now, we leave society with a diminished resource of some importance.
Well, of course you always tell the truth, but how many of us ever get on the evening news in more than 23 seconds? Can you give the whole story in 23 seconds? You have to selectively give bits of information.
And if the scientists and the media have connived to make a good story, the politicians have not been slow to see the advantages to them.
We would be taking a great risk with future generations if, having received this early warning, we did nothing about it, or just took the attitude, well, it'll see me out.
Why do you think it is that politicians, and indeed Congress, have been convinced that there has been global warming?
I don't know that they've been convinced, but their business is to be responsive to their constituents, and their constituents are convinced. It would certainly not be in their best political interest to not act convinced, would it? So the people want to believe this, and politicians have to respond somewhat to the people's wants. They can't say to their constituents, you are stupid, can they?
It may not quite add up to a conspiracy, but certainly a coalition of interests has promoted the greenhouse theory. Scientists have needed funds, the media a story, and governments a worthy cause. And beyond that, is it the millennium that encourages notions of an apocalypse? Or simply that in a world without belief, we need a catastrophe to give us something to believe in, where for once, in a battle between nature and humankind, we can line up on the side of good against the forces of evil.
I mean, this thing is being fought with dull knives and Zipcos. I don't know if you realize that. There's a lot of blood on this thing.
In what way?
People hate each other about this issue. You haven't noticed that? You ever seen a nastier scientific issue?
Why do you think that is?
I don't know. I guess because people passionately feel that it's a battle between good and evil.
If the consequences of the greenhouse theory did not extend beyond a moral crusade, it could be left to those with a religious turn of mind. But it cannot be so lightly ignored.
Would you march down the road toward a policy which people have rightfully said requires an economic restructuring of the world, knowing that the world was behaving opposite to what the basis for that policy said?